and then I join this line. Okay, it is cutting the circumference at this point, and then I join this with this.
Like a square?
It will be a square, definitely. I'm not drawing it with the compass and a ruler. That is why it is turning out to be a little bit different. But if you have it like more than the diameter, the only thing is the arcs will go outside. But still you would have the same line. And once they intersect here, you just always do the same thing. Okay. So questions about it? None? Okay, so now I'm going to ask you to do something. Okay, before I do that, there is an important question that I think I need to mention about.
Sir, I have a question. So on book page 798,
Yes.
I was having hard time solving this problem.
Oh yes, yes. Let's go over it. Okay.
Please.
So let's read it all together.
Thank you.
So let's read.
Marcus correctly reasoned that the sum of the angle.
No. Start from the top. Start from the top. Critique reasoning.
Okay.
Read it.
Okay. Marcus said he thought some information was missing from one of his homework problem because it was impossible to answer the question based on the given information.
Very good. Very good.
The question and his work are shown. Critique Marcus' work or reasoning.
And reasoning. Okay. So let's see what is his work. So he has this quadrilateral. Label the sides A, B, C, D. And again, I think in your book the convention is they are naming these vertices clockwise.
Counterclockwise.
Yeah, but it is done usually counterclockwise. So this is given as x minus 2. This is given as 6z minus 1. This is given as 2x minus 28. This is 10z plus 5. Okay. So what is he saying? He's saying, okay, what is the sum of angles in a quadrilateral?
360.
360. So what is he doing? He's adding up all these angles. X minus 2 plus 6z minus 1 plus 2x minus 28 plus 10z plus 5, and he's saying it equals 360. Notice, isn't that what he does?
Yes.
Okay, so after simplifying, what he gets is 3x plus 16z is equal to 386. Okay, so now the question is, in an equation, if you want to solve it, how many variables do you want?
Two. Oh, so
One.
One.
And this one has how many variables?
Two.
Two. So he's saying, okay, since I have two variables in one equation, I cannot solve it.
Sure.
So his reasoning, that part is fine. But he's missing a key thing, which is what? Read further. So read where it says homework problem.
Okay. Find the measures of the angles of quadrilateral ABCD which can be inscribed in a circle.
Which can be, this is the important point, inscribed in a
Circle.
Oh, so he's missing that. What if it is inscribed in a circle, they have not drawn the circle, then what is the property that we could apply?
Opposite angles equal 180.
Yes, the key thing is the sum of opposite angles is
180.
180, which means now we could just add these two
x minus 2 plus 2x minus 28.
equals 180. Okay, well when you add these
3x
3x
minus
180 minus 30 and 3x is equal to 150, which tells you x is
No.
equal to 50.
oh, plus
That should be positive 30.
positive.
Because
Okay, okay.
on the left it's subtract.
Great, thank you. That tells me you guys are awake.
That's 10.
210.
So,
That's 70.
Yeah.
Very good, very good. Okay, so now what is the key thing? The information was fine. He did not either read it or he did not know what does inscribed mean and what the property does this particular quadrilateral have. Once you know the theorem, you know that, okay, some of these two is going to be 180, some of these two is going to be 180, and you can find x and z. So
Yes.
definitely he is missing that particular point. Okay, now I would like you guys to do something. Go to page 800 of your book. And I give you guys a few minutes to do these problems. And we can look at one of these. All right. So, which ones do you guys think is very interesting? What do you think about number 8? Should I do that one?
Yes.
You can do that.
Yes.
Yes. Okay, so let's look at number 8. I think that is very, very interesting. Let me erase this and then we will have the whole board to our disposal. So if you draw the diagram, it's like this. Okay, so the rest of it is, they're labeling it L, M, N, B. L, M, N, B. Now notice in this case, they're labeling it correctly. L, M, N, B, going
Oh, yeah.
so there is actually, okay. So LMNP is a quadrilateral inscribed in a circle. Measure of L is equal to measure of N. Is MP, is this line the diameter of a circle? The question is it?
Yes,
Okay, give us the reason why.
because it is like half of the circle.
Well, I mean, it looks like half of the circle, but that's not the reasoning. Mathematics. So I could have like this, but it is not passing through the center. It might be just a little bit off, a little bit off.
Yeah.
You have to reason it.
Angle N and L equal 180,
Mm-hmm.
and B and M equal.
Well, they haven't given us that the
Specific-
measure of
Specific.
yeah M and P is. Yeah, I mean, of course, you can argue that some of these two is 180. That is fine, but notice what would happen. I showed you guys that even if the quadrilateral is here, this is not even passing the center. Still, this rule applies. That doesn't tell us anything. There is something key that. So, what was one of the theorems that I reminded you from the last time? Angle subtended by the arc
Semicircle.
at the circumference is
Half of the
half of that at the center.
Center.
Okay, so notice this. Okay, this is a straight line. Would you guys agree with me?
Exactly.
Yes.
So what is the angle subtended over here?
180.
Okay, why?
X.
Why? Because this is 90. This is the arc that is subtending it. Do you guys agree?
Yes.
If this is 90, then the angle over here
Should be.
should be 180. I mean, this is a straight line. It is 180, which means, okay, it must be that this is passing through the center and it is touching the two vertices. So it must be that it is MP is a diameter. Because how do you define a diameter? It passes through the
Center.
Center of half.
yeah. So that's how we know. And that is exactly what they would reason actually. So they're saying, since LM and P is a quadrilateral inscribed in a circle, the opposite angles of quadrilateral are supplementary. So your measure of angle L equals measure of angle N. And their sum is 180 that we agree with. They are congruent and supplementary angles and must therefore be right angles. Since angle L is right angle, by the inscribed angle of the diameter theorem, MP must be the diameter of the circle. Okay, go to page 801. Ask me any question that you want. Does anyone have page 801? Okay, any question that you want me to do? Pick one.
Let's do question 11.
Okay. So let's look at number 11 then.
If the opposite angle must be like supplementary, how about the parallel angles?
What do you mean by parallel angles?
Like the same one, A and D.
No, there is no condition on those.
No.
If, so remember what you're confusing. If you have two parallel lines, so I'm going to draw parallel lines in any direction, there is a condition for this transversal. If this is 50, this one has to be 130.
30 to make 100.
Okay, because this is the condition for parallel lines. This is not suggesting anything about the opposite lines being parallel. So, no problem. Okay, so now let's look at number 11 as Andrew pointed out.
Okay.
He wants this one. Okay, by the way, there is something else also that I want you guys to note. This is a very good question to note that thing. Can anyone tell me what do I want you guys to see over here in this particular? Can anyone read my mind? Let's see. Because students oftentimes try to guess the mind of the teacher. So I want you guys to try to guess what do you think is important in this particular problem. Okay. Immediately.
Solving for Z.
Yes, we are solving for Z. That is asked for in the question. So what are the important angles in this particular? If you want to solve for Z, what are the important angles in this particular case?
A, B, and A and C and B and D that are opposite.
Exactly. Do we have measure of D?
No.
So does B help us?
No.
No, it should not.
Yeah. Because A and
So A and C are the ones that are helpful.
yes.
Yeah.
B is given as redundant. You should be always careful to cross out the redundant information. Okay? So we have measure of angle A plus measure of angle C equals 180. Okay, so we just add them 4Z minus 10 plus 10Z, 10 minus plus 5Z is equal to 180. And these two would cancel. You guys agree?
Yes.
9Z is equal to 180. So you would have Z is equal to 20.
Yeah,
Very quickly we have been able to do it. Okay. So the last thing for today's lecture. Anything that you guys want, that you have not understood and you want me to clarify, you want more detail about it. Anything.
Everything is clear. Thank you so much.
Yeah.
Okay, great,
It
great.
was good elaboration.
Uh-huh.
Thank
So
you
let's do then number 21 on page 803. Yes. Oh yes, this is a very, very good question. I think so. That is why I wanted to do this one. So anyone has this? Yeah, David, go ahead. Read this question for
Yeah,
us.
sure. For 21, this is a represent real world problems. A patio tile design is constructed from a square inscribed in a circle. The circle has radius of 5 square root of 2 feet.
So this is the design of the tile. Okay. So the radius of the circle is, this is 5 square root of 2 feet. Okay, cool. And what are they saying? Find the area of the square. So we need to find this area first. Okay. So what is the formula for the area of square? What is the formula?
S square.
Yeah, by x, what do you mean by that?
S square, like S could be like in a way this like 3 or 3 squares.
Yeah, so the key thing is it is the side of, by s we mean the side of the square.
Yeah.
Any side. Now, the measure that they've given us is this 5 square root of 2, the side of a square. Is it the side of the square? Remember, I'm telling you, these are the sides. Is this the side of the square?
No.
No.
That's
That's the key observation. Okay, so which means that the first step should be, we need to find the side of the square. Okay, well can we do it? Remember this is a circle. what do we know about the radii of a circle? Is this the radius of a circle? This is the radius of a circle. Do you see any other radius?
On the left.
This is also radius. What about any other radius?
Up, the other
Okay.
is one and the down.
Down.
Okay, good. So, what other properties do radii have? There is a key property that we need here. Isn't it that all radii of a circle are equal in length? Isn't that true?
Yes.
So if this is 5 square root of 2,
Yes.
what should be the measure of this one?
5 square.
5 square is the same.
Okay, very good. That's the key thing that I want to point out. Okay, if this is 5 square roots of 2, then this is also, thank you, also 5 square root of 2. Okay, well, this is a triangle that is being formed. It is a right triangle, okay? Because if this is a square, the diagonals intersect at right angles, okay? So you know that. Now this is a right triangle. If I know this side and I know this side, can I find this side?
Yes,
Yeah.
Pythagorean.
Pythagorean theorem, or Pythagorean theorem, which means, so the side, I'll call this side S, okay, we wanted S. So S squared is equal to 5 square roots of 2
Plus
squared
square
plus 5 square root of 2 squared.
square.
Okay, so the answer, when we square this, you will get 50.
Okay.
This will be 50. So S squared is equal to 100. What should S be?
That's the 10.
Okay, very good. Now I know the side of this square, which is 10, which means what should be the area of the square?
Area of square is
Very good. So let's write the formula first. Area square is equal to side squared, and therefore it is 10 squared, which is 100 square feet. Okay, that's the first part. You pointed out this question, that's good one. Okay, now what is the next part?
Alright, shall I read it?
Yeah, go ahead.
Find the area of the shaded region outside the square from
Okay.
part A.
Yes. So this is part A. We are done with it. Now this is the shaded region. How would we find the area of this shaded region?
We can use the formula of circle.
Uh-huh.
Area equals pi r square.
Yes, very good. So the first step would be find the area of circle, which is
Pi r square.
pi r squared. What is the radius?
100.
Radius is
No.
radius is
5
5
sorry.
square root.
Square root.
Uh-huh. Which gives us 50 pi.
Mhm.
That's the area of circle. But that doesn't give us the area of the shaded region.
We can
What's the-
subtract
Subtract what?
x,
5.
which is 10.
The area of the square. Okay? So which is square of 10. So
That is
then
100.
then shaded area is equal to area of circle. Then I write subscript
Mhm.
A for area of circle minus area of square, which is 50 pi minus
Minus
100. That's it. All right. I hope you guys have understood this particular topic. Any questions about it?
Thank you so much for
Thank you so
clarifying.
much.
I hope you guys do the homework and meet you guys next time. We'll move on.
Thank you.
Alright, thank you, sir. Thank you so much.
All right, guys.